name. So without class name, class created. That is anonymous class. Anonymous class is a one type of inner class which has no name. Next point. Anonymous class is always subclass of a class or interface. Anonymous class is a subclass of a class or interface. Anonymous class is a subclass of a class or interface. Anonymous class is a subclass of a class or interface. It is a subclass of a class or subclass of interface. It is always subclass. It is superclass is not possible. Anonymous class as a superclass is not possible. Compulsory one subclass. Either one superclass will be there or super interface should be there. Then only possible. But it is always inner class also. So it is as a outer class not possible, as a superclass not possible. So anonymous class as a outer class not possible. Anonymous class as a superclass not possible. Anonymous class is a one type of inner class which has no name. It is always subclass of a class or interface. If you want to write, first you have to write one outer class, one superclass, then only possible. Okay. Now, this is listen with more concentration, little bit complicated syntax. Syntax is little bit complicated. Suppose here I'll write interface test. Okay. Now void show. Is it abstract method or concrete method? Abstract or concrete? Abstract. Is it valid abstract or invalid abstract? Valid? Sure. But abstract keyword required in Java, no? Implicitly abstract. That's what valid. It is valid only, no? In interface, all methods are implicitly public abstract. So it is valid. Here, which access modifier present? Public. Here default is public. Here default is public. Inside the class default is no name. But inside the interface, public. Now, one line I'll write. Is it valid or not valid? Give me answer. Test T equal to new test. Is this line is valid or not valid? This line. Valid or not valid? Why it is not valid? Interfaces cannot be instantiated. Creating objects are not possible to interface. Studied no? Interfaces cannot be instantiated. Objects cannot be created to interface. But if you write like this, valid. If you write like this, valid. Now, this is complicated syntax. You have to listen with more concentration. Syntax is like that. If you write like this, what will be happen is one class created. Is there any class keyword? Class name also not there. That is anonymous class. If you write like this, one class created. There is no class keyword. That class name also not there. That class implements test interface. But implements keyword also not there. You observe? There is no class keyword. There is no class name. There is no implements keyword. That class object created. If you write like this. But you already studied whenever interface is inverted. Whenever interface is inverted, then what we have to do? Whenever interface is inverted, then what we have to do? All abstract methods must be overridden in a subclass, or subclass must be declared with abstract keyword. Otherwise, compile time error occurs. Now, if I run this program, error comes because we didn't override this method. Now, if you want to override inheritance required, Here inheritance also is there. Here one class created, that class implements test interface. So this method we have to override, then valid. Now, if you want to override, overriding rules you have to follow. Here which access modifier present? Public. Here what is required? Public. Public void show. System dot out dot println welcome. Now you observe, if you write like this, what will be happen is one class created. There is no class keyword. Class name also not there. That is only anonymous class. That class implements test interface, implements keyword also not there. That class object created, that object assigned to T. With the T, you can call show method. You observe? File, save. I'll compile. Java C demo.java. Java demo. Running now. In this program, how many interfaces are there? How many interfaces? One. What is that? Test. How many classes are there? How many? Two. What are those? Demo, anonymous class. Demo and anonymous class. So test interface is there. One demo class is there. One anonymous class is there. Now, if I compile this program, 3 dot class file generated. 3. You observe? Compilation. First, I'll delete all dot class files in my system. Delete star dot class. All deleted. I'll display dot class file. There is no dot class file now. File not found. I'll compile now. Compile. Now, delete display dot class. See, 3 dot class files. dir, it will display dot class files. Now, here what is it? Demo dot class, test dot class, demo $1 dot class. Okay. Now it is anonymous class. So dir star dot class, all will be displayed. Dot class, demo dot class, test dot class, demo $1 dot class. This demo is outer class, one is inner class. That is anonymous class. Name is not there. Okay. This is anonymous class concept. To understand this one, some other code I'll give, then you will get a more clarity. First you write this program, example 1. Example 1. So here one class created. I'll give you notes to understand, or some other code I'll give you. With that, you'll get a clarity. Is it completed? Suppose if you write like this, now whatever I written here, now this code, just you assume another way. Here class name, implements, test. There is no class keyword, there is no class name, there is no implements keyword, like that. Assume. Now public void show system.out.println welcome. Now test t equal to new anonymous class object t dot show. So that code you assume like this, then you'll understand. Now if you write like this, you assume like this. See, here we don't have class keyword, but class created. We don't have class name. That is only anonymous class. That class derived from test interface. Implements keyword also not there, like this. Method overridden. That class object created. It is not test object. Test subclass. Test subclass object created. Anonymous class object created. Anonymous class object assigned to T. It is subclass object assigned to super interface upcasting. Valid. With that show method called. So like this you assume, then you'll understand. Okay. If you write like this, you assume like this for understanding. Okay. Write this one. Otherwise that code you cannot understand. Understanding purpose, that code. So if you write like this, one class created, that class name not there, that is anonymous class. That class inherits test interface. Okay, implements keyword also not there. That class object created, assigned to test interface. Okay, with that called show method. Here for calling show method, we used object or object reference. Object reference. Now we can use object also. How to use object, I'll show you. Is it over? So this code you assume like this to understand. Okay, then you will understand. Now what I'll do, see here. Here I'll remove test.t. Here dot show. Now which object created? Anonymous class object. That object dot show. Now it is valid. It is one more way. See, compilation, execution. Now you observe. Anonymous class is there. Anonymous object also is there. One more concept introduced, anonymous method. That is only lambda expression further. Java 8 feature. Then this total code just in a one line we can write. That is further. Today not possible. Many concepts required. Functional interface, set functional interface annotation is all required. So 10-15 lines code just in a one line we can write. Java 8 features. So 10-15 lines code just in a one line we can write. That type of concepts introduced. Okay. Further I'll explain. Now this is one more example. Write this one. Example 2. I didn't get you. Here previously object reference was there. This is previously. Now what I did, I removed test.t. Here I added dot show. That means anonymous class object created. That object also anonymous object. You studied demo d equal to new demo you can write. Only new demo also you can write, no? That new demo if you write anonymous object like that created. The syntax is like that only. Now anonymous class, anonymous object. So here in this only class created, that class inherited, that class object created, with that only called like this. Write this one, example 2. For explanation also nothing is there. That is syntax like that. Syntax is like that. That's what, whatever I given the right side code, no, like that you assume. Then you will understand that code. So is it test object? No. Test subclass object. Test subclass is anonymous class. That object. Okay. If you write like this, anonymous class object created. Anonymous object created. That dot show. Further, this is most important where we use, you'll understand. By using this concept, 10-15 lines code we can write in just one line. We can concise the code in further programming. Okay, we can reduce the number of lines of code by using this feature. That is, you will understand further. Is it over? So here the class bound with one more class. That is only encapsulation also we can say. It is also encapsulation related. Binding of one class with another class. Okay. And now, is it over? Inner classes completed. Okay. Next concept, packages. Next one, packages. Say with the packages, object-oriented programming will finish. But still many topics are there. Don't think course is not completed. Okay. Say after packages, you will see string handling and wrapper classes. After this, exception handling. After this, Java streams and serialization. Network programming. Okay. Collections framework and generics. Multi-threading and synchronization. New features from JDK 1.1 to JDK 20. Before completing batch 20 comes, 20 also will teach. Okay. Before completing a batch, 20 also coming. Just after 10 days, JDK 20 also coming. Now present 19. So before completing batch only 20 comes, up to 20 I'll teach. After package, these are left. Okay. These many topics are there still. Here. It is the most important topic. It is the most important. These three most important topics only. Okay. Except these two. Except these two, all important only. Except these two. Remaining all important only. Okay. So after package, these all will be there. Now package, note on. A package is a collection of sub-packages, comma, classes and interfaces. A package is a collection of sub-packages, comma, classes and interfaces. A package is a collection of sub-packages, comma, classes and interfaces. A package is a collection of sub-packages, comma, classes and interfaces. See, once if the package topic, if it is completed, now parallelly you can attend Advanced Java also if you want. Now, no need to wait until completion of core Java. Parallelly, Advanced Java possible. Okay, parallelly you can learn. Now, a pack up to exception handling required, and exception and the string handling wrapper classes 3-4 days it will take. Exception handling wrapper, this also it will take 3-4 days. So that's what parallelly you can learn Advanced Java if you want. A package is a collection of sub-packages, classes and interfaces. See, classes and interfaces you can group together as a one package. What is the need of packages? See, for example, our hard disk here divided into two drives, C drive, E drive. See, you will create 4-5 drives also generally. Here they created 2 only. Now generally we'll create 3-4 drives, C drive, D drive, E drive, F drive. Okay. And again in the drives, folders. These are folders. Okay. folders, again in the folders, again subfolders, again subfolders, again subfolders, files, like this will maintain. Now just assume folders are not there, drives are not there, only one drive, all files there only. Then very difficult to manage file system, no? So if drives and folders are there, very easy to maintain, very easy to search. See, generally what you'll do, you'll create 4 drives: C drive, D drive, E drive, F drive. All softwares you will install in C drive. Okay. But if without drives, only one drive is there. With only one drive is there, all if it is in one drive, if Windows is corrupted, then what will happen? You'll format. Your all remaining data also vanish. No? That is the reason we'll create drives, more than one drive. If any Windows corrupted, that particular C drive only will have format. Remaining drives data will be there as it is. Okay. That is the reason always will prefer more than one drive. Okay. Now C drive, D drive, E drive, F drive. Suppose you created 4 drives: C drive, D drive, E drive, F drive. You created 4 drives. C drive, all softwares will install in C drive. Whatever you downloaded software dumps, you will place in D drive. What are the programs daily you are writing? In E drive. And F drive, entertainment files, your photos, videos, images, graphics, like that only you are maintaining, no? One drive for entertainment purpose. Movies also, audios also, videos also, everything. One drive. Now in E drive, you are writing maintain programs. What you'll do, you'll create some folders. Java programs, one folder. C programs, one more folder. HTML program, one more folder. Oracle SQL programs, one folder. Like that, you'll maintain. In Java folder, again you'll create core Java folder, advanced Java folder, J2EE folder. Like core Java folder, again string handling, exception handling, separate folders. Like that, if you maintain, suppose you record one collection program, you'll go to E drive, you'll go to Java folder, in that core Java folder, in that collections folder, you'll open, you'll search. It becomes easy to maintain. If all are in one place, difficult to maintain, difficult to search. That is the reason you are creating drives and folders. Same style, while developing projects, project may contain hundreds of programs. Your project, suppose you are developing one website. One website having 5 modules: mail module, chart module, games module, sports module, news module, like that we have. Okay. In your website, mail service you are giving, chart service, games, sports, news, many things you are providing. Then what you can do, mail related programs in mail package, chart related programs in chart package, games related program, games package. Like that, you can make it separate. So while developing projects, this concept required. Project may contains hundreds of programs. Mail related programs in one package, chart related programs in one more package. It is nothing but it's like a folder type. File class, nothing but file type. Every class one dot class file generated, that is file. Every package one folder generated, that is folder. Next, write it. The Java compiler generates dot class file for every class and every interface in a source file. The Java compiler generates dot class file for every class and every interface in a source file. The Java compiler generates dot class file for every class and every interface in a source file. The Java compiler generates dot class file for every class and every interface in a source file. Source file nothing but .java file. Suppose in a one program, 10 classes are there. 10 classes are there. If we compile, how many dot class file generated? 10 dot class file generated. That is starting session only given. Okay. Next, The Java compiler also generates folder for every package and every sub-package. The Java compiler also generates folder for every package and every sub-package. The Java compiler also generates folder for every package and every sub-package. So in a program, package is there, one folder created. Sub-package is there, one more folder created. One more sub-package is there, one more sub-package folder created. So package equivalent to folder, class equivalent to file. So every class, every interface dot class file, every package, every sub-package folder. So classes are equivalent to files, folders are packages are equivalent to folders. Okay. Suppose first, how do you want to maintain your project files? You have to decide. Suppose while developing projects, what will happen? .java programs, .class programs, we have to maintain separate. For that, two folders will create. Suppose src folder, classes folder. Now src folder. Here classes folder will create. Okay. .java files in this folder. .class files in this folder. .java in this folder. .class in this folder. Will create separate. Why separating? Suppose you'll develop your own website. After developing that website, if it is in your home PC, only you can access. That website, if you copy in server, worldwide accessible. Then what you'll copy? .java you'll copy, or .class you'll copy, or both you'll copy? .class only or to copy. .java also if you copy, they'll see your source code, no? Your project code they can see. What they'll do, they'll change the logo, they'll change the address, they'll make it their own website. If you give like that. So you should not give .java files. You should copy only class files. While developing only, if you make a separate, that is exact classes folder directly you can copy, no? That's what. Further, you are going to see Eclipse, MyEclipse, NetBeans, IDEs. There, what will happen? Automatically separated. Here, manually you are separating. They're automatically separated. Now, classes. In this, suppose your project is 5 modules are there. Then create 5 packages. Mail package, chart package, games package, sports package, news package, separate. Present here, I'm giving like this. Pack 1 package. Pack 2 package. Like this I'm creating. Okay. Now, in this, again, if sub package is there, sub package also create. Not there, directly .class file. Suppose a.class, one file. Here, one sub package I'll create. Suppose pack 11 sub package. In this, one more file, b.class. In this, one more class, c.class. I'll create. Now, .java files are here. A.java, B.java, C.java, these all. Main program, separate. One more package. Main program, it is one more package. Suppose test package. main program here, main dot class. Always will maintain home page or main class separate. Execution starts there. That is separate will maintain. Let's will maintain. Now, what I'll do, you observe, these all I'm going to access. These all I'm going to access in this program. See, every day you're seeing Java C demo.java, Java demo, like that. Now, dot Java there, dot classes here. These all I'm going to access here. With this knowledge, your dot Java can be anywhere, dot class can be anywhere, you can access from anywhere. That knowledge you'll get it. Later, according to your requirement, you can make a structure, you can create. Now, see in C drive, src folder contain .java files. Classes folder contains all .class files. Main class separate program, separate package. These all I'll access there. With this knowledge, .java program can be anywhere, .class can be anywhere, you can access from anywhere. That is, you'll get it. While developing projects, 5 modules are there, 5 packages create. Sub modules are there, sub packages create. Like that, you divide. Then you can maintain projects easily, project files. Suppose in your website, mail, chart, game, sports, news, we have 5 modules. Mail related programs in mail package, chart related program in chart package, games related program in games package. Like that, you can maintain. Suppose in the mailbox also, inbox separate, spam separate, trash separate. If you want, sub package also create. Inbox related programs in inbox package, spam related program in spam sub package, trash related program in trash package. You can make it separate. That is, you are going to learn. Right, this one. So if you use Eclipse, My Eclipse, NetBeans, automatically these all generated separate. Okay. We'll see that is that type also further. Is it over? Now here these folders, SRC folder, classes folder, we have to create. But packages are there, no? Those folders are created by Java compiler. So pack 1, pack 2, pack 11, test. These all created by Java compiler. But these two folders we have to create. Now here, all packages are folders. But all folders are not packages. What do you want? All packages are folders. All folders are not packages. So this SRC folder only, not a package. Classes folder only, not a package. Okay. Now these are packages. These are folders also. Which are I given word package, no? These all created by Java compiler. I am not going to create. Those folders are created by Java compiler. But these two folders we have to create. Now, how to create? We'll see now. See, directly what you can do, you can open folder structure here, directly C drive, you can right click, you can create new folder. Possible, no? So here already folder is there. 1 minute. The previous batch folders are there. I'll delete. Same names are given. Now from here itself you can create. Right click, new folder. You can create. Okay. But otherwise, everything from command prompt also possible. Say MD SRC folder created. MD classes folder created. So if you write like this, one SRC folder created, one classes folder created. You can see here. C drive SRC. See, just now created. Okay. Now here classes just now created. Now it is empty. This folder is empty. Classes, this folder is empty. Now according to folder structure, SRC folder, classes folder. Now we are going to write Java program in SRC. CD SRC, change directory. Here start notepad a.java. Directly you can open like this also. Say start notepad a.java. Write this all. MD means make directory, CD means change directory. Directory means folder. In DOS operating system we call directory. Windows operating system will call folder. So MD SRC, that means make directory. MD CD, change directory. Directory nothing but folder. Make directory SRC, make directory classes, make change directory SRC. So two folders created. Later we entered into SRC. Now a.java file I'm opening. Start notepad a.java. Is it over? See, it will ask, cannot find the a.java file. Do you want to create a new file? Yes. Now you can write the program. Now, a class in which package? Is SRC folder name. A.class in which package? pack 1. So package pack 1. Okay. Package pack 1. Now we are creating one package pack 1 in that class. Don't write. First listen. Class A. One method I'll write. Void add which takes integer A, integer B. Here system dot out dot println A plus B. Now here which access modifier present? No name. Nothing but default. Default scope is within the package. Within pack 1 only can access. But I want to access in main class. Main class in which package? Main class in which package? Test package. Diagram I given no? Main class in test package. That one, this method I want to access there. Is it possible? No. Which access modifier required? Public required. Then possible. But if you want to access this method, A class object required. No? For creating object, this class also must be public. Then only accessible. Now, pack 1 is a package. In that A is a class. In that add is a method. Write this one. File, save. Package pack 1. Package pack 1 semicolon. Public class A, public void this one. Now add method in A class. A class in pack 1 package. Now I given the Java compiler generates something I given like that. You see the notes. The Java compiler generates dot class file for every class and every interface in a source file. Next point. The Java compiler generates folder for every package and every sub package in a source file. That is a given. Now, if I compile this one, what will be generated? One folder, one file. One folder generated pack 1. One file generated A dot class. If I compile, say file, save. I'll close. If I compile Java C A dot Java, one folder generated, one class generated, file generated here only. But we don't require here. Where we required? Classes folder required, not here. That's what Java C minus D. Minus D if you write current directory src omitted if you write like this. But where you want to place? C drive classes. So what I'm saying to compiler, generate dot class file in this folder. First what I'm saying, omit current directory. It is omitted. Where you want? Here I want. Which file? A.java. Now minus D omits the current directory. It is a destination directory. If you write like this, what will happen? See, compiled. Now I'll open src folder. src. Here what is there? Only A.java. Back classes. See, one folder created. Just now created. Now when I compile, no, then only created in that a dot class. See, in a classes folder, pack1 created, a dot class created. So if you write like this, what is the meaning of this line is here, it omits current directory. It omits current directory. Now what I am saying to compiler, omit current directory. Which is current directory? SRC. That is omitted. It is destination directory. It is destination directory. It is destination directory. It omits current directory. It is a destination directory. Note. So what we are saying to compiler, generate in classes folder. We are showing destination. We are saying omit this, generate here. Then it is compiled and placed here. Ready, son? You have to compile the program like this. Now a dot class and pack1 folder generated in classes folder. So a dot class and a dot class generated in classes folder. A dot class pack1 folder. Both are generated in classes folder. If you write like this. So what we are saying to compiler, omit current directory. Then once if it is omitted, where you want to place destination. Is it over? So if we compile like this, then only other location generated. Now, next, start notepad b.java. Yes, write this one also. Start notepad b.java. Start notepad b.java. Now, a B class in which package? Pack11. Pack11 which package? Pack1. That's what we have to write like this. Public class B. Public void cube. Write this one. Is it over? Now if I compile, what are generated? pack11 folder b dot class. This is already present. Okay. Now file, save. See what we have tried. Java C -d C drive classes b dot Java. Alright, sir. Next, start notepad C dot Java. Now, b dot class generated, pack11 generated in classes folder. Start notepad C dot Java. Now, it is in which package? Pack2. Public class C. Suppose public void max. If A greater than B, system dot out dot println A. Else system dot out dot println B. That is one. If I compile this one, what is generated? Pack2 folder generated, C class generated. Is it completed? Say Java C -d C drive classes C dot Java. You can write this one. Is it over? Now see C drive src folder. What are there? A dot Java, B dot Java, C dot Java. Okay, A dot Java, B dot Java, C dot Java. Back classes. See pack1, pack2. In pack1, A dot class, listen. pack 1 a pack 11 a dot class, in pack 11 b dot class, back pack 2 c dot class. Whatever we required, like that only generated. No, now main program. Now start notepad main.java. Note last one, start notepad main.java. Start notepad main.java. Start notepad main.java. Now main class in which package? Test package. So package test. This one don't write. First listen. Class main. Here main method. Public static void main. Now this one we are not going to access outside. That's what it is without public given. Those all we are accessing here. This one we are not accessing there. That's what public not required. Now I want to call add method. Add method in which class? Add method in which class? A class. A class in which package? Pack 1. You have to import the package, no? Import pack 1 dot star. That means all classes and all interfaces included. A equal to new A. With this A dot add two numbers. Now B class. B class purpose which package? Pack 1 dot pack 11 dot star. Then B equal to new B. B dot cube. One number. Next C class. Pack 2 dot star. Now C class. C equal to new C. Now C dot max. Okay. File save. Write this program. Pack 1. Now in this star, is it pack 11 included? Is it included? No. Star meaning only classes and interfaces. That is starting session I given. Star meaning only classes and interfaces. Sub package not included in star. This is for A class, this is for B class, this is for C class. I imported. So star contains only classes and interfaces. Sub package not included. A class in pack 1, B class in pack 1, C class pack 2. But star meaning classes and interface only included. Sub pack is not included. That's the reason sub pack is explicitly out to import. Now give me answer how to compile this one. First, is it completed? Is it completed? Now give me answer how to compile. Java, Java C, -D. Next. Now, is it recorded in classes folder? No. Next. What did you write? C:/. You should not write test. Test is going to be created. Have we written pack 1 here? See, have we written pack 1, pack 2? That is created. Only C drive. Test is going to be created. Test 2 who will create? Test is a package or normal folder? Package that is created whenever you compile main.java. Now, main.java compiled, placed in C drive. But in a C drive, pack 1, this one also. Pack main.java. Main.java compiled, main.class generated in test package. Test 2 folder also generated in C drive. If you write like this, but you'll get errors. 9 errors. You observe? Nine errors. You observe. Pack 1 does not exist. Pack 1 does not exist. These all. How to solve these errors? Tomorrow I'll explain. Class path setting record. It takes time. That network is not working properly. That's what tomorrow we'll see. Next class purpose, we have to solve that problem. Tomorrow we'll see. This is I'll explain tomorrow, not completed.